Hey, everyone. Welcome. Thank you for coming. Good to see we have nobody napping yet. I know it's an hour or so after lunch, so thanks so much for staying awake. To get you a little bit warmed up, thought I'd ask you a quick show of hands. How many of you are familiar with Active Directory? All right, great. So in the right session. Good to know. It's pretty much all of the room. And for the 3 people who maybe didn't raise their hands, it's OK. There's many resources you can go check out later. The other question, how many of you have had some experience with Google Cloud Platform, getting a VM up, creating a network, and doing some basic infrastructure as a service? OK, so this is probably about half the room. And pretty much everyone has experience with AD. That's great. So you're in the right session. We're going to be talking about how you can extend your on-premises Active Directory to Google Cloud Platform. My name is Siddharth Bhai. I'm a product manager with Google Cloud. I focus on problems that work with identity and security. Very excited to talk to you today, and even more excited to have with me 2 very talented co-presenters.
Hi there. Ben Miller. I'm a systems administrator with Google. I work on the mergers and acquisitions infrastructure services team.
How you guys doing? I'm Kenny Hill. I'm with Capital One Identity and Access Management. I focus on directories in the cloud.
Great. So we'll go ahead and get started. So what I thought I'd start off with is, honestly, an apology. I'm sorry. We're not going to cover the heated issue of whether we should call it on-premises, or on-premise, or on-premise, or on-prem. We'll take that debate to the evening hours. But 2 things in particular I'll leave you with today. One is, as the show of hands showed, a lot of you do have Active Directory deployed, so we understand that. And B is, leave you with some best practices and guidance on how you can extend your Active Directory investments you've already made onto the Google Cloud Platform. So in particular, the things we'll cover is, how is it that you can use your on-premises Active Directory, where you do your users and groups management, to get identity and access management configured on GCP. We'll talk about some drivers and architecture choices for actually running AD on GCP itself. After that, we'll have 2 great case studies coming up of actual experiences of having run AD on GCP. And we'll round it off with some best practices. So the first thing that we're going to cover is, how can you extend your on-premises Active Directory users and groups onto GCP for identity and access management? This is probably the question I get asked most often over the last year or so, because a lot of you have put in that investment to start working, to have Active Directory all set up. Your auditors are happy. Internal security team is sign off, which is great. And now you want to start getting started with GCP. So can you leverage those existing investments? And the answer is yes, and I'll show you how in the next 2 slides. What's coming up is probably a fairly familiar topology to a lot of you. You probably have your users and groups in your on-premises Active Directory. They're sitting in your Active Directory domain controllers. And then, for a variety of reasons, several customers have either ADFS or Ping or Okta or any of these other federation products deployed. So you can take those on-premises users and get single sign-on to a variety of other relying parties or applications. And so the question is, when the application is Google Cloud Platform itself, how is it that you can connect the 2? So a canonical use case that comes up, as we often find, that is customers. Maybe somebody gets interested with BigQuery and wants to go ahead and set things up so that a certain group of users can go ahead and do things with BigQuery. So the way that you do it in GCP is via role-based authorization. So if you were a BigQuery admin, you could then go ahead and essentially do a variety of things with BigQuery. So how do you set it up? I have this slide coming up. I'll let you soak it in for a second. It's Google Cloud Identity. There's a lot of things on the slide, and it's a full identity as a service product. I won't be going too deep into it today, but I did want you to know it has identity, it has policies, a very strong support for device management. But there's 2 features in particular, which is all we need for the question we set it out to answer. And those 2 features are, A, it allows you to sync your users and groups from on-premises Active Directory onto a Google Cloud Identity domain. B, you can set up your Google Cloud Identity domain to indicate that you'd like the authentication of those users to happen with your on-premises federation endpoint. And by going ahead and using these 2 features, you can have your users and groups from on-premises Active Directory be used for BigQuery or any other IAM in GCP. So let's go ahead and take a look at that in this demo. OK, so as my screen comes up, what you're looking at should seem pretty familiar to a lot of you, since you're experienced with Active Directory. This is the Active Directory Administrative Center. Now, for the purpose of the demo, I need to go ahead and reestablish my RDP. As it comes up, what you'll see is I have a Active Directory Administrative Center open in the on-premises environment. Great. So this should look familiar. It is your on-premises Active Directory. I have created an OU in here for GCP, which is currently blank. So I'll go ahead and run a simple PowerShell script. And what the script has done is it's gone ahead and pre-created for you some users and groups. So as I refresh, I have 3 users in my on-premises Active Directory, Alice, Bob, and Charlie. And I have a group, GCP Security Admins, which has Alice and Bob as its members. So this is what you have set up in your on-premises AD. Probably simulates a lot of deployments you have today. I'll now go ahead and switch onto a VM where I have Google Cloud Directory Sync set up. So what this is doing is it'll go ahead and take the users from that OU and groups and sync it up to a Google Cloud Identity domain. So one thing I should call out is a lot of you, if you've been using GCP, G Suite in particular for a while, you may be familiar of a term Google domain, which is the same thing as a Google Cloud Identity domain. So I'll go ahead and sync these up. What this is doing is it's now pushing those users and groups into Google. So I'll switch my screens. And what you're now looking at is the admin console for Google Cloud Identity. So as I refresh my screen, the 3 users we just created, Alice, Bob, and Charlie, are now available in the Google Cloud Identity domain. And as I go to the Groups UI, you'll see the group, GCP Security Admin, is also available here. So I'll go ahead and take this group. And it's now all come up from your on-premises AD into GCP. So what next? Now let's go back to the thing we were trying to do. To do that, I'll apply this group. You're now looking at the IAM page of a GCP project. And I'll go ahead and add a role. I'll give the users of this particular group, which we just synced in from your on-premises AD, the role of BigQuery admin. And so as I go ahead and hit save, you now see that this group has BigQuery admin IAM on this project. Now, the interesting thing here, as we come back to our slides, is effectively that you have this set of groups, these set of users who can be added in or out of your on-premises AD group and have the access changes reflected back on GCP IAM without needing to go ahead and do anything special into this IAM page. So as we come back to our slides, please, what you will notice is we will have 2 additional items coming up onto this IAM policy that I just showed you pretty soon. One is you will be able to say that allow these users to only have access for a specific time window. So the one at the top is the policy we just set up, but down below is a special expression that will allow you to essentially have your group sync ahead of time and say only for that hour or only for that month are those users allowed to have access. And second is you'll be able to further restrict it based on the source IPs that they're actually connecting from. So that's the first part of the session where we saw how you can use your on-premises AD, extend it onto GCP, and use that for IAM. And this is where we come to an interesting transition. And it's a slightly tricky point to make, so I need your help. Everything we looked at so far was having your on-premises AD extended onto GCP without requiring VPN by syncing your users and groups into your GCP domain. What we'll now go and take a look at is if you are trying to run Active Directory or AD-related apps on GCP, how do you go ahead and do that? And for this, we do not need cloud identity or a VPN to be set up for the things we're going to talk about next. So let's jump in. So a lot of times when you need Active Directory in the cloud is if you're thinking of a migration project. So go ahead and soak in that visual for a second, and I'll talk through it. So what you're seeing is you have an application that's talking to your on-premises Active Directory over a set of Active Directory protocols. Now, what are the cases when you may need Active Directory as you think of moving this app or the server onto GCP? So one very common use case is if you've gone ahead and domain joined these applications onto Google Cloud Platform, onto Active Directory, and you want to run them on Google Cloud Platform. So in that case, you're looking for AD. Another case is if the app does LDAP or Kerberos or Windows Integrated Auth, it's looking for a domain controller. The next set of things is if the app has logic for retrieving things that are stored in Active Directory itself. Most often, it's group-based membership when the application houses the authorization logic in itself. Another time is if you had used a AD client-side library. For instance, you had a .NET-based app, and if that was making any calls over to system.directory services, it would look to find a domain controller. And the last bit is when you do go ahead and have your application migrated to the cloud, you have a choice to make, which is, do you still want your on-premise network to be on the critical path for each application authentication, lookup, or would you rather have it scale in cloud, have low latency, and have the cloud application be independently and highly available? So how is it that these choices end up manifesting your architecture options? Let's take a look. First thing you can do in any of these cases is the simplest. Just go ahead and set up your VPN or cloud interconnect and have your Active Directory continue to reside on premises. And so this way, it's pretty quick to configure, but you have higher latency for all your applications. Every single request is going back to your on-premises network. So what do you do? Second option you have is you can go ahead and choose to deploy read-only domain controllers onto Google Cloud. Now, the advantage in this case is it's a read-only replica of Active Directory, but those of you who have worked with it for a while will probably know that there are certain operations that are still being chained or referred back to your full domain controllers, which in this case would reside on premises. So your app's still going back to your on-premises network for getting those done. In terms of a positive, this does not bring in everybody's credentials onto any cloud deployment. So you can have no users' passwords in the cloud by default. Some of you may like that from a security perspective. However, and it also lets you only have replicated in a certain set of users' passwords into that cloud AD deployment. On the other hand, the biggest challenge with RODCs is there's application compatibility things you should think about. So if you go and Google for RODC application compatibility, the first link gives you a list of apps that support RODCs or do not. So that's something to factor in. The next option is to go ahead and deploy your writable or regular domain controllers into cloud. And in this case, you obviously have your Active Directory data available entirely on GCP. It's low latency because your application is then going for all operations to the ADDC you just deployed there. However, the thing to keep in mind in both this as well as the previous config is if you have multiple Active Directory domains, you may end up needing to deploy domain controllers for each of those domains into cloud. So if you had a merger and acquisition use case, or for any other reasons had 3 or 4 AD domains, talking about multiple domain controllers from each of those domains. So to get around that, another thing you can do is set up a new Active Directory domain on Google Cloud Platform, use the Active Directory trust relationship model to establish a trust with your on-premise AD. And this does work well because you effectively are able to have 3 or 4 different AD domains where our users are having their credentials stored and authentication happening. However, all your resources and applications which are running in the cloud can join or just work against the Active Directory domain, which is now hosted fully within cloud. Another thing you could think about when you think of moving to the cloud and having a hybrid deployment is to consider having a disaster recovery site on Google Cloud Platform. And so what the numbers you're seeing on the right effectively show an example of AD site replication costs, which you could utilize to go ahead and have things set up so that your users and applications on premises are usually not reaching back to the cloud, and only in the event of a failover will they come in and use the cloud DCs. So these are 5 options you have in terms of architecture. And by this point, you're probably wondering, which of these makes sense for your specific use case? Now, to help answer that, I'm very excited to share with you the highlight of our segment today, which is the Ben and Kenny experience. They'll come up and share with you what is it that worked for them as they look to have AD running on GCP.
Hi again, guys. First, I want to thank Sid. I want to thank Ben for allowing me to come up here and share a little bit about Capital One's Google Cloud Active Directory journey. Hopefully there's time at the end for questions. If not, feel free to connect. Always really excited to hear what others are doing in the identity and directory space in the cloud. See the question up on the board or screen, why extend Active Directory to Google Cloud? There are many reasons. The main driver for us is resiliency and speed. Let me explain a little bit of what that means and some of the design inputs that went into some of our decisions. The four main areas we focused on with our domain controller design. First one, security. I'm going to gloss over that and skip it. Not enough time for me to really dive deep. Ben is going to share some security practices. Next area for us is directory size. Since going all in on the cloud, we've had exponential growth in our directories, running at a 38 and 60 gigabit NTDS DIT, have about 2.5 million objects in each directory, between 100, 150,000 both users and group objects. Understanding directory size, there's many reasons for our growth. One of the main ones that I'm excited about is the development we've had on cloud platform of applications requiring role-based access. We've also kind of taken the concept of tags from cloud and we're writing more data into our directory. This allows us to correlate Active Directory objects with cloud things, utilize it in our provisioning system. Next area is resiliency. The next is speed. As I was doing the slides for this, I realized same inputs really went into both of them. To ensure Active Directory authentication and authorization is always available. Doesn't matter if it's a federated SAML authentication, a Windows authentication, LDAP application bind, a database authentication, directory needs to be there. Same holds true when you're domain joining infrastructure and it wants to scale. So the directory needs to be there. So for us, going down interconnect or VPN, that wasn't really an option as we want to, no matter the situation, ensure that we can scale applications. To create a seamless experience for applications when switching projects and regions. A developer, application team, DevOps team, no matter what you call them, they should not need to know anything about AD sites, maintain different URL mappings. We even have application teams that they don't even know it's Active Directory on the back end. When they need help, they ask, where's the LDAP team? To provide the fastest domain join, directory replication, and LDAP experience possible. Key way to be successful in this bullet is to keeping your traffic on Google Cloud. I'm not going to give exact time test metrics. You guys, I highly recommend testing this yourself. In a world where every millisecond counts, it is important to ensure that traffic stays on the most optimal path. And this is probably one of the biggest reasons we build domain controllers on Compute Engine. To quickly rehydrate and be able to increase AD capacity. At Capital One, we rebuild all infrastructure every 45 to 60 days maximum. Domain controllers are no exception to that rule. They get rebuilt. We call this rehydrate. So we are constantly rebuilding our domain controllers. That's why directory size is up there. Need to understand your build times. It's important to know exactly how long it's going to take to build domain controllers. Even if you're using an install from media file, which you back up the AD database, your sysvol, you import it. If you have quite a few objects, the domain promote process is still going to do like a checksum. I don't know the correct term for it, but of every object, and that's where the lag's going to happen. So understanding your directory size and the speed that you can build domain controllers is going to help you determine, is your directory small enough? Are you able to auto scale? If so, I'm jealous. Or are you going to have to run it monitoring a little bit over your monitoring high peaks, meaning you're running a little bit over capacity at all times? Or do you keep a reserve pool of live domain controllers running on smaller instances in a reserved AD site, and you utilize scaling technology to kind of bring them in and out as you need them? Next, I'm going to show you a few of the high-level design decisions. In a typical traditional AD site topology for on-premise, you'd usually have a single AD site or two per data center. Each of these AD sites is usually going to have some sort of single point of failure, if it's power, network, shared storage, or other infrastructure. In our Google Cloud model, we put domain controllers in every zone available in each region we deploy. This is essentially treating the whole region as a single AD site. This provides a more resilient topology. In the on-premise model, it's hard to test if you manage your sites and services and your cost and for next closest site, and there can be errors in it. You can shut down network to a data center, and you can know that everything's authenticated and authorizations occurring, but do you know exactly where all that's going? In this model, the cloud, you know it's just staying in the same site. This also ensures that any applications that utilize DC locator process are going to pick domain controller in the AD site, in region, staying on Google Cloud as their primary. For applications that cannot utilize DC locator, we utilize an LDAP load balancer. Our configuration for load balancer, LDAP Secure 636, GCS, Global Catalog Secure 3269, coming into the load balancer. This ensures that all traffic outside of the project is secure. We then terminate at the load balancer to regular 389, 3268, and point at domain controllers across multiple zones. We utilize Global Catalog Secure Port for applications which chase referrals. Many Java-based applications chase referrals, and sometimes you have COTS products deployed which you cannot disable it. If you're not familiar with chase referrals, it's when you point an application to a domain controller, and instead of utilizing that domain controller, it pulls back all the A records and randomizes them per the client, and then just picks a random one. If you utilize Global Catalog Port, it disables referral chasing. We're predominantly a Linux shop, which does not have DC locator process by default without third-party products. There are also many applications which are not AD site aware. They cannot utilize a load balancer, or even some of the horrible applications that you have to point directly to a domain controller. An example of one of those applications you'd point directly at a domain controller is something that needs to read and write almost simultaneously, like your identity and lifecycle management application or a provisioning application, where if it doesn't read and write at the same one, you could have collisions. We utilize a root DSE query, so LDAP-S root DSE query to the load balancer, returning the DNS host name. The applications can utilize this. They can put it in a script or a job and ensure their configuration is always pointing at a live domain controller. Even if we're rebuilding or rehydrating our domain controllers, if they have this job set up, they'll know they always have a live domain controller. As I mentioned, it is extremely important to ensure we are replicating Active Directory data as fast as possible in this model. If we were to fail to another region, applications need to be able to read the same data that they read in one region in another one. Also allows us to more effectively get to a just-in-time access model and enhance our privileged access password rotation. The legacy replication strategy was designed more than 18 years ago when network was slow and also very expensive. We choose to utilize a full mesh replication with change notification strategy. Change notification treats replication on the site link same as it would inter-site. So in the diagram I'm showing up there, we are replicating from site to site on-premise to all of our Google regions, and then we do as fast as we can replication between the sites. To close out, a couple more lessons that we've learned along the way. Limit your use of group policy objects. There are many more cloud-friendly configuration management solutions out there. Ben's going to actually show you one that's available for free that works. You can also harden your image, stack all your configuration settings in your image, and that's another approach. Managing group policy deviations and exceptions in a cloud model is not operationally efficient for the directory support teams or the application teams. The application teams are going to need to script moving the objects or adding to a security filter group, which means they need credentials, which means they have to also secure a password. So we don't take that approach. We only deploy GPO for high-level settings, which there's no way we're going to reverse. Monitor and log everything. Even if you're not going to utilize the data immediately, you will want it later. There are many other services besides Compute Engine, which can enhance directory services in the cloud. So you will want this historical data when you're building out tools and applications on Google Platform. Automate your domain controller build. I already mentioned this one. It's worth repeating. Ensure your build process for domain controllers is efficient and you're able to quickly add capacity. Domain controllers are in a different category of core services than regular applications. The domain controllers need to be there before the applications need to consume it. Another thing is AD, all of you who are very familiar, it's extremely chatty. Wait until you put it in the cloud. When teams are auto-scaling, they're spinning up 1,000 instances at a time, pulling them down, AD is going to be chattier. So being able to add capacity really quick is important. Last thing I'll leave you with. At Capital One, we do not troubleshoot isolated domain controller issues in the cloud. We will give it one reboot. If that issue persists, domain controller comes out, we bring another one in. Thank you guys for sitting and listening to me. Thank you, Sid.
Thank you. That was actually a very, very interesting set of experiences. You heard Capital One talk about how they're running Active Directory in production on GCP with a fairly large-sized state. The two angles in particular that stood out for me was, one is, even when you're looking to run something like Active Directory, which is a very core Windows Server workload, trying to do LDAP, by leveraging cloud DNS and cloud load balancing, it was interesting to see how they designed the LDAP load balancer. That's definitely something, things like this, as you go ahead and explore of moving to the cloud, are interesting ideas to try. The second was the message that we were left with, which is you should go ahead and look to automate your domain controller creation, the domain controller build process. And that's actually a great point, and I'm excited to call upon Ben, who's going to come in and share with us more about what is it that Alphabet does when it also deploys domain controllers in production, and how is it that you have automated DC build. Welcome, Ben.
Hi. As I mentioned a bit ago, I work on Google's M&A infrastructure services team. I work with a group of talented systems administrators in Colorado and California that built and operate the project that I'm going to be talking about today. One of the things that our team does is to build and maintain core IT infrastructure for an array of acquisitions and partnerships. To make this happen, we rely heavily on code and automation. Our project, GECCO, is code-driven, managed IT infrastructure for Alphabet entities and acquisitions, deployed in Google Cloud. The problem that we set out to solve was consistent management of many unrelated Active Directory domains rather than a single large forest, as Kenny was describing. With a fairly small team, we manage services like Active Directory, DNS, DHCP, NPS, and Radius for many small to medium-sized environments. In order to accomplish this, we put tremendous focus on using the DevOps approach of infrastructure as code, using code and automation to deploy and maintain these environments and minimizing manual changes. So I'd like to share some of the key design goals that informed the design of GECCO. And I'd propose that these are goals that most of you would share if you're building out domain infrastructure in Google Cloud. I'll give you some examples of how we got to where we are, but just understand there are many other ways to achieve the same goals. So let me break each one of these down. First, it's important to limit access to the GCP projects that contain your domain infrastructure. Protecting your domain controllers from malicious or accidental action is critical to the security of these environments. So we build domain infrastructure in isolated GCP projects. Having ownership or instance admin roles in GCE means having tremendous power over the instances that run in those projects. For example, depending on your IAM roles in the project, you can create or delete instances, you can access their logs, create new Windows accounts, and change passwords on those machines. So we use role accounts and custom IAM grants to give just the access needed to resources in our projects. We only allow folks that are domain admins in the environment to become instance admins in the projects that they run in. We carefully consider the consequences of granting even lesser access to compute resources in the projects that contain these domain controllers. Approach every cloud IAM grant by asking yourself, can someone use this access to escalate their privileges in the domain? Will this grant let someone modify instances, metadata, or access sensitive logs? So, okay, now we built our domain controllers in an isolated project. Fantastic. They're running perfectly, smoothly, nothing's going wrong, they're under glass, and nobody can talk to them. So what do we do next? First, we use instance tags to define VPC firewall rules that control the flow of network traffic within our project. This ensures that we know where all of our traffic is coming from and where it is going to. Once these rules are in place, we can establish network connections to our customers' cloud and on-prem environments. We want our infrastructure to be available and performant, so we do a couple of things. We co-locate our instances in the same GCP zones that our customer projects run in, and then we use cloud VPC peering to create fast network connections between the virtual private cloud networks of these projects. Finally, we interact with on-prem networks via Cloud VPN, again, placing our compute instances in cloud regions that are close to those networks. Our next design goal was to automate provisioning and to implement source-controlled configuration management. Infrastructure as code is key to scaling IT as a service, but we're not just concerned with shaving down provisioning time. By centralizing our code and config in source repositories, we can force all changes to go through peer review and a suite of tests. With sufficient provisioning and configuration automation, you might choose to build new instances rather than applying updates to existing ones, as Kenny described. You can bring new instances online and ensure they are operating correctly before bringing your existing capacity offline. And with GECCO, our instance provisioning automation is built around getting our configuration management in place as early as possible and making sure that it stays in control. So we automate deployment of new domain controllers and other instance types using a couple of stages. So for the first stage of our instance build, we take advantage of the sysprep specialized stage of Windows installation to inject our build artifacts onto the machine. This is possible thanks to the GCE agent that runs in the stock GCE image that we build our instances from. It will look for a script configured in the project or instance metadata, and then it will run that script. All we're doing in this initial stage is to download build artifacts from a canonical source. So here I've highlighted a very short PowerShell script where I'm storing as a value in a hash table. And when I pass that hash table to the commandlet below, the key value pairs in the hash table become instance metadata. So when I provision the machine, the GCE agent will go looking for the specialized script in metadata, and upon finding it, it will execute it. As I said, all this particular script is doing is copying instance build artifacts from GCS. Now, I could instead be using a Git repository, or I could be using a package repository, or something else. The important thing is that all of the build artifacts that I'm using are coming from a vetted source. Everything that I'm using to build this instance should be centrally stored. Everything that I'm using to build this instance should be peer-reviewed or should be built by something that was itself peer-reviewed. After the sysprep specialized stage completes and the instance reboots, our second stage script is triggered. Now, this script will install configuration management prerequisites, initialize the configuration management system, and then shepherd it through its first run of config management to make sure that it completes successfully. For our domain controllers, we use PowerShell desired state configuration as our configuration management system. So here I've given you an example of the DSC configuration required to create a brand new domain controller on a Windows Server core machine. That's really about it. The Windows feature DSC resource ensures that the AD domain services feature is installed, and the XAD domain resource handles the creation of the domain. In a production environment, you're going to see a lot of additional code and configuration to handle things like credential management and testing and other things that are specific to your environment, but this really is all there is to creating a new domain using PowerShell DSC. Speaking of credential management, the final thing I wanted to touch on was protecting your secrets. Building domain infrastructure necessitates handling some very important credentials, including those needed to create a new domain controller or a new domain entirely. Everyone at some point is going to be tempted to put a password in a script. We've all been around the block. Don't do it. Don't use plain text. Don't just use obfuscation. ROT13 is not encryption. Really encrypt your secrets. Store them in a place where you will have an audit trail every time they are accessed. Have sufficient logging in place to know when those credentials are used anywhere in your environment. So there are a lot of ways to protect your credentials, but I wanted to show you a pretty simple example that's enabled by Cloud Key Management Service, or Cloud KMS. Cloud KMS allows you to encrypt and decrypt secrets based on Cloud IAM access grants. So I can have one set of accounts that has permissions just to encrypt secrets, and then I can have another set of accounts that just has permission to decrypt secrets. Here I'm using a very simple gcloud command to encrypt a plain text string and store the results in a file. Then I'm uploading that file to Google Cloud Storage. And when I need to use this very secure password to join my domain controller to my domain, the code can retrieve the encrypted file from GCS, decrypt the secret, and inject it into my configuration management without the plain text password ever landing on disk. Now we could, if you imagine, just take things a step further and build a process where no human ever has to know what certain passwords are. So you can imagine having a process to generate a random password as part of an automated provisioning process. So let's say that I have a password for a break glass administrative account. The right service account in the right place will be able to access this secret in order to set the password for the break glass account. But no human will ever have to know what this is. If OnCall uses Cloud KMS to decrypt the secret, I'll know about it thanks to my audit logs, and the same process can be triggered again to automatically rotate the password. So in summary, when building domain infrastructure in GCP, you should carefully consider these aspects of your design. Limiting access to just where it is needed and isolating your domain infrastructure, automating your provisioning and deployment and using configuration management, and protecting your critical secrets. Thank you very much. I'll hand the rest of the time back to Sid.
Thank you, Ben, so much for joining us. The two key takeaways, I think, from this segment for me were, one is like sort of an operational step-by-step of how can you actually automate DC build using tooling, which is hopefully familiar to a lot of you who've been working with AD for a while. Second was you saw Ben talk about what's a good way to go ahead and protect secrets in the cloud, in this case, for the Active Directory use case. But using Cloud KMS and GCS storing the encrypted secret, it's something you can extend for other applications you do with GCP too. As we go into the sort of final section of the talk, I wanted to go ahead and touch upon and bring together some of these best practices. This is obviously not a complete list. You've heard some very great pearls of wisdom from both Ben and Kenny. But I thought I'd leave you with a few things to keep in mind as you start thinking about running Active Directory or extending it to Google Cloud. The first set of things is around Active Directory design. So one of the things you should think about as you move to cloud is there's no reason to not be highly available. So for domain controllers, always have at least 2 DCs, 1 in each zone. Second, when you think about your Active Directory site topology, you have 2 options. One is you can pick a simple option, which is you create a single Active Directory site for all of GCP, and using the power of our multi-regional VPC, you're effectively able to have that work well. It's a quick way to get started. Second, you heard Kenny describe, especially as you move towards more performant applications, to have 1 site per region. And what this will do is, for any of the applications or servers you have running in that region, they will always go to the closest domain controller, and so you'll see low latencies. In terms of connectivity back to on-premises, there's networking options, Cloud VPN, Cloud Interconnect. You're welcome to go study those more and see which one works well for you. That's because a lot of Active Directory operations require non-internet, like private network, line-of-sight connectivity between domain controllers, as many of you are probably aware. The last part is, for any applications or servers you choose to move to GCP, and you do have 1 or more AD sites on GCP, placing them in the same Active Directory site will lead to the right type of things happening, which should keep your DNS and AD operations working well, finding the closest DC. From an operations and security angle, a few things to keep in mind. One is there's obviously a plethora of choices when you come to cloud for running compute. You obviously want to make, just like you would if you were purchasing hardware to run your domain controllers, make the right type of choices. Preemptible VMs may be cool, but probably not a good idea for running AD domain controllers. You want to think about static IPs and things like that. In terms of GCP IAM permissions, you saw that being something we covered in the last 2 case studies, but I did want to hone in the point. Here's something to keep in mind. If you have a domain controller running in a VM on compute, anybody who has compute instance admin on that GCP project can go right-click, reset Windows password, and effectively elevate themselves to a domain admin. Now, just like you wouldn't very loosely put your Active Directory on-premises domain controllers in physical environments you didn't fully trust, when it comes to managing it in the cloud, especially in GCP, you want to be mindful of which type of IAM permissions you have on those projects. In particular, anybody with set IAM policy is able to set IAM permissions on that GCP project and give themselves or other a variety of IAM roles. So it's generally a good hygiene to keep in mind, but especially when you're running domain controllers, be mindful of that. Second, we have a resource hierarchy within GCP, which is beyond the scope of this talk today. But to give you an idea, you can have projects which are inside of folders, which are inside of organizations. And so there is an inheritance model of IAM permissions there, too. So I see several of you nodding. I won't go into more detail, but something to study and keep in mind as you're thinking of running AD. Lastly, if you wish to have more isolation for AD, you can always set up a Bastion Active Directory project. It is more things that you'll have to configure, but did want you to know that is an option for high security cases. You can then still use VPC peering and shared VPCs to have all your domain controllers in that project, but have your servers and applications in other projects that can still reach those domain controllers. Lastly, there is a session later this week. I have a link in a couple of slides, which will talk about how you can use hardened security on Google Cloud Platform for all of your sensitive workloads, including AD. So I encourage you to find out more about that and look to leverage that. So if all of this is sounding interesting to you and you want to get started, I wanted to leave you with just a few quick slides of examples of things you can do. One is we have a Google Cloud solution that talks you through step-by-step how you can get your highly available Active Directory domain up on GCP. And I have a slide with all the links in a minute if you want to take a photo of that. Second is you can also choose to extend an existing AD domain onto GCP. So there's a white paper. Phase 3 of this white paper talks about Active Directory considerations. There is a click to deploy. If you wanted to go ahead and just get an AD domain spun up and start playing with it and experimenting with it, we have that, something you can go ahead and leverage. And a lot of what you've heard today is focused around 2 themes. One is having high available multi-regional Active Directory on GCP, and B has been around specifically automating domain controller creation. And so for that, I'm actually pretty excited to share with you what Itopia has done. So Itopia, is a partner who we've been working with for the last several months. They have a very interesting set of things they're announcing right now at Next. In particular, the ability to extend an existing Active Directory domain, and the ability to have multiple sites, one site per region, similar to how you heard Kenny advise and talk about how they're doing it in Capital One. They have a booth down below if you want to go and get automated support for everything that you've heard about today. I encourage you to go check them out. So here are some links if you wanted to go back and play with it. I wanted to thank you all for coming, and please let us know if there's more we can do in GCP to help support these use cases. Thank you so much.